Welcome back to the Astrocast. I'm your host, Drew. Today is Wednesday, April 15th, 2026. Hope everybody's doing well. Still reeling from NEAF 2025. Man, what an amazing trip that was. And I'm here to tell you, I've got some really cool stuff coming up. Very much looking forward to sharing it. It's going to be a little bit different than what you'd probably get from most creators. I was thinking about this, and after watching some of the videos from some of the creators that were on the floor at NEAF, I pretty quickly decided that I should not be the guy who just sits there and records table after table of new products, because honestly, that's not what you guys are here for. You're here because I would assume you like to hear the story of astrophotography and how it excites me and what I enjoy about the hobby, etc. So to that end, I am trying to tell the story of actually going to NEAF. So I've got all of the media. Obviously, we just got back home yesterday into Charlotte, made quite a long trip driving there and back. And I'm not really going to say anything more than that, except to stay tuned, because I'm going to be dropping a very, very, very cool episode in the very near future that I hope you all will very much enjoy. But to that end, we have a very cool episode today. So I'm actually going to be interviewing a friend of mine. His name is James. And if you have listened to the show at all before, you've probably heard me talk about the filter that he has created, the Leviathan Optical Spectral Pro. And this is a phenomenal filter that has been made for people like me and possibly you who shoot one-shot color but want the best possible results from their filter if you're in a light polluted area. And I firmly believe, after having tried many of the light pollution filters on the market, that James has truly created something special with his product. Now, I will say we recorded this last week, and since then, First Light Optics has actually agreed to stock the Leviathan Spectral Pro. So James is located in Dublin, Ireland, and obviously shipping here to the States can be a bit confusing, but we have a lot of listeners in Europe who shop via First Light Optics. So if it's something that you're interested in getting your hands on, you can do that now at First Light Optics. I will have a link in the show notes that you can use. It's my own affiliate link to get to First Light Optics. And from there, just click on that link and then search for Spectral Pro or Leviathan Optical, and it'll come right up for you. But I won't spoil too much other than that. I just wanted to make sure you know that it is actually available on one of the stores. And if you're in the States, you, of course, can reach out to James, and I'm sure he'd be happy to talk to you. You can also order from his website directly, and he does ship internationally. So I'll have all of that information for you in the show notes, so be sure to check that out. Make sure to tune in later this week. I've got 3 pending episodes that are all really awesome in their own ways. So super excited to finish editing those and drop them for you, and a whole lot more to come on NEAF. So stay tuned for that. But for now, I will pass it over to Pastor. We have a very special guest joining us this week on the Astrocast. I've actually spoken about his work quite a few times over the last year, and I have been very, very happy to be a demo tester for him. So I'd like to welcome from Leviathan Optical, James. Welcome to the show, James. How are you today?
I'm doing great. Thanks for having me on, and it's nice to catch up again.
I know, man. We got to talk on the phone a couple weeks ago, and we have
wanted to do this for a long time, but we just haven't been able to make it happen because obviously we got a time difference and we're both very busy, and it's just like there's always something going on. So it's cool that we were able to finally like nail down a time and make it happen. I missed the first one, and I apologize for that because we had actually apparently already set a date last weekend, and I completely, or 2 weekends ago, and I completely missed it, so my bad for that. But
oh, that's all right. I think the messages were confusing. So it's
fine. Well, dude, like one thing I noticed, and there's not a good solution for this, unfortunately. I have like so many different messaging platforms, and I've learned that I can't have notifications on them like at all because I just will constantly be bing, ding, ding. You know, I'll be trying to eat dinner at 7 o'clock at night, and me and my wife are like watching TV or something, and it's ding, ding, ding. So like I decided, 6 months ago to just like, all right, I will do this on my own schedule. I'm turning off all the notifications. But when you got something that you want to pay attention to, that can make it tricky because you're not getting the ding, ding, ding in your ear all the time. And yeah, that kind of sucks, but
yeah, it's tough, and it's hard to manage then. Like, because I do the same. Like, I have like all notifications off all apps except for like a few specific individuals.
Yep.
So it's easy for things to slip by.
Yeah.
And then it's annoying again if the apps update and reset your notification settings, and you have to redo it all.
This is a bit of a tangent, but like I've been getting more and more anti-smartphone over the last year. Like, I don't know. It makes me cringe. Like, don't get me wrong. I love playing on my phone just as much as the next guy, but like all the social media, like I only get on social media now really for the Astrocast. Like I do the Facebook page because I know a lot of people follow there, and I'll post updates there occasionally and stuff. But otherwise I kind of try to stay off of it because it's just, I don't know, man, it's a war zone out there and it's not good.
Yeah. And it's kind of addictive as well. It's hard to not look at your phone in a moment's peace.
Addictive. Absolutely.
And honestly, since starting the business, I've had to be more online than ever, so it's actually gotten harder.
Yeah. Your location probably makes that difficult. Where are you right now? Tell the people where you're from.
Dublin.
Yeah, I figure your accent kind of gives it away.
Yeah, but it's funny when I'm in Dublin, people always ask me where I'm from.
Oh, do they?
Yeah.
Why do you think that is?
Because I've lived abroad, and then after living abroad, I've always worked in international groups, so I've kind of just picked up international English. So to foreign English speakers, I sound Irish, but to Irish speakers, I sound foreign.
Huh, that's interesting. Yeah. I'd never considered that. I was going to say, you do have a bit of a unique characteristic to your voice that I haven't had a lot of Irish friends over the years, but I've talked to a few. And it does have a little bit of a unique draw to it. So I'm in the States.
Well, there's a funny story to how I kind of learned that. I had to learn that the hard way.
Really?
I lived in the States. Well, it was like a holiday in the States for like 3 months in San Diego. Nice. And for my first week there, I was having the strangest conversations with people. I was talking to people and they were just like not answering me back in ways that made sense to what I said to them, but they're being very nice.
Uh-huh.
And it was only on the 7th day, and I was lying in bed at night, and I kind of thought, it's my accent, they don't understand me.
But they're trying to be polite. Oh, yeah. I think he said
so the next day, I tried this one trick where I just started pronouncing more, like all the letters and all of the words, and all of a sudden people started to understand me a lot better.
Wow. Go figure, huh? That's funny. Because I guess you don't really consider it. It's just your voice, right? It's such a natural part of yourself.
Yeah. But then soon after, I was like living in the Netherlands for 9 months, and so I was working with a lot of Dutch, Belgian, French, German people.
Cool.
So it then kind of stuck. So I ended up speaking this like international English for like quite a long time before I came home again to.
I wonder if that's more and more typical these days as we become more of a global society. I bet you it is, huh?
I think so as well. A lot of people say I have an American accent. That's probably just from like watching a lot of American TV.
Yeah. Because you were telling me, and this is something I'd always been curious about. Forgive me before we get into AP too much, but you said that like a lot of the pop culture stuff in Ireland is exported from the U.S. So like,
oh yeah, absolutely.
Movies, TV, music, all that kind of stuff.
Yeah, like I'd almost say that like within certain groups, or my friend groups at least, that American media is essentially culturally dominant.
Wow, that's
Yeah,
crazy. I mean,
yeah,
I guess it makes sense, but man, I tell you, in this day
yeah,
and age, it's crazy, man.
yeah. I haven't said that now. There is like at the same time like a really like Irish culture resurgence, because like Irish media in Ireland is having its own resurgence recently. I was telling you before when we last spoke, there's a band called Kneecap, and I was recommending you watch their movie, and this is kind of more of a modern age you know, aspect of Irish life, even though like they're from Belfast and it's quite different to Dublin, but it's really inspired a lot of people to get more into like Irish language and Irish culture.
That is very cool. I think it's probably number one on the list of places that me and my wife would like to visit together. We even went so far as to buy a travel guide to Ireland when we were at Barnes and Noble one night. We've never done that for any other country, so it's definitely up there. Actually, I've got a friend, actually a coworker, Cassidy. She travels to Ireland every year for a couple of weeks. They just love it. And I don't know if she's got family there as well, but she travels there quite a bit. But you said you had moved around a lot. Why were you moving around, if you don't mind me asking? Was it work related or pleasure or?
Well, I haven't moved around that much, but what like I done that internship. There's a program called J1. So most students, when they leave school, there's a program where you can go and do work abroad in the United States for, I think it's like 3 to 6 months. I stayed for 3 months, and then after that, I did an internship with the European Space Agency. So I was living in Leiden in the Netherlands for like 9 months, quite
Oh
soon
man,
after. Yeah,
what
and
was
then
that like?
oh, really cool. Like it's like one of the it's silly. It's like one of the most fun jobs. It's one of the most incredible places you can work, and it's a bit mind blowing that I was accepted. I wasn't expecting to be accepted, because like my university, they had this program and saying you need to spend at least 3 months working. And I didn't like any of the options they were giving me, so I asked them, can I find my own? And I applied to some, and this is one of the ones I applied to, and I was accepted. So I was never really expecting it. It was like the dream, and
Yeah,
it was
just like
accepted.
throw it out
So
there into the universe and see if it comes back, right?
yeah,
Maybe.
exactly.
Yeah.
And I got the call to go, so I went, but I managed to extend it for like 9 months instead. It was
Nice.
great. And like when you first walk down the corridors and you see they have like life-size models of the satellites and the spaceships and things like
Oh,
that, and like that's the first thing you do when you walk in. You walk down this long corridor with all of these like instruments and satellites and rockets, and it's like really inspiring. Like the first thing you do when you walk in there, and it gives you goosebumps.
that is really cool. What did you get to do while you were there interning? I mean, I know an internship doesn't necessarily mean anything glorious, but what did you get to do?
Uh, so I was working with the Space Environments and Effects department. So largely what they were responsible for doing was like with satellites in particular, modeling the radiation environment that a satellite in a certain orbit would be susceptible to.
Wow,
So if you know
that's
like
interesting.
the magnetic field of the Earth, you've got Van Allen belts. So you've got protons and electrons circulating over those magnetic fields.
Hmm.
And they can impact some of the instrumentation on satellites, but you can also have, particles from deep space coming in and
Yeah,
impacting the.
and
So
depending
on
on where
Earth,
you are in orbit, you get more or less, right?
exactly, yeah. On Earth, it's not such a problem because like the atmosphere absorbs a lot of that radiation, but satellites in space are really sensitive to it, especially because the skins of the satellites often have to be razor thin or even foil.
Yeah.
So what you're doing in that department is not only modeling the particle load coming in on
Yep.
the sensors and sensitive electronics, but then modeling how thick the shielding should have to be, or maybe instead, if you can't make it thick because of weight, you reorientate the satellite at a different part of the orbit.
Ah,
You know,
yeah.
yeah,
See, that's very interesting stuff. It's and you said that the shieldings are extremely thin, and I guess that makes sense because they want to make it as light as possible for getting into space, right? Because every
yeah.
gram is money.
Yeah, and sometimes you can just make it thicker with aluminium, or sometimes you have to make it thinner, or accept that that's the life cycle of the instrument.
Now, when you would test these things, was it theoretical testing, or did you guys have a way of actually like bombarding different materials with radiation to see how they would react?
So if you imagine what the European Space Agency, it's like they have a lot of testing in-house, but a lot of the instruments in this specific department are made by subcontractors in some of the different companies. So that some of these instruments would be made by private companies, and they might have done in-house testing on the sensors with the different shielding.
But you have to kind of design and model it all out and how it's going to work.
So you're working together with the contractors in that case. So for this specific department, we worked with the contractors' data and testing, but also in the European Space Agency, they have their own testing facilities, which are very cool, actually. And I was saying on that first day that we walked through, the best one was there's non-destructive testing, but the best one I got to see was the destructive testing lab, where you're just smashing things into other things to see when they break. That is cool. That was quite fun to see. But the other thing, like walking through there, they brought us through as a group because they were introducing us on our first day, and they handed out this random thing, and they said, what does that smell like? And, they said, well, that's burning electronics. And they're like, yeah, that was part of like the AC system on the ISS. So I got to hold something and smell something like a piece of electronics that had burnt out on the ISS.
Wow, that is really cool.
So they had brought it there to like do a post analysis.
Man, that is super duper cool, man. I love that. What do you think about the ISS looking like it's going to be deorbited in the coming years? You got any thoughts or feelings on that?
It's complicated. It's cool that it's up there. I think it should stay up there. It's complicated.
It's definitely
other
complicated.
things are going to go up as well. I think they should keep it going because it's such a great legacy over time.
I agree. That's kind of where I feel like I understand.
It's a legacy from the space race as well, because like after the space race, there has not a decline in the interest in space, but doing it, how exciting things are that are in space is like a little less since the space race, and this is one of the last really cool things.
That we can see
legacy.
Quite frequently here from the ground as well. I mean, my wife just rolls her eyes and she's like, I get it, the ISS, but like for me, I'm like a kid in a candy shop. Every time I see it go overhead, when it comes and goes after months at a time. And then all of a sudden you're seeing it every other night for a week. I don't know. I light up every time I see the ISS. I actually was able to capture it when we had the big aurora storm on May 10th, 2025, or 2024 rather. You remember the huge one that broke out. And actually one of my photos, I captured the ISS trailing for, I think, 10 seconds. It was a 10-second exposure with aurora and the ISS. And like, no one knows that looks at the photo. They just see a smudge of light, but I'm like, that's the ISS because I looked it up in Stellarium the next day when I got home. So,
well, what matters is that and that other people,
exactly.
some other choice people will know, and we all know it's cool.
Absolutely. Yeah. Well, James, man, thank you for coming on the show to talk with us. We're just going to take a quick break, and we'll be right back with James from Leviathan Optics. All right, welcome back to the Astrocast. I'm your host, Drew. We're sitting here with James from Leviathan. This is one of the more interesting origin stories I've heard. It's funny, we just started naturally kind of getting into your background, but I always ask people, like, how did you get into what you do and how'd you get into the hobby of astronomy? But it sounds like it's largely been space and astronomy or what have you has been a passion of yours for quite some time, judging by what you've been telling me so far.
I think that's partially true and it's partially not true. Because I, unlike a lot of other guests I've heard on the show, and maybe a lot of other people you talk to who are really into the hobby, I can't really admit to having like a huge passion for astronomy my whole life because, to be honest, I didn't know that much about it until I went to college and studied it. And it's another story why I ended up studying physics with astronomy in college. But it was only through that exposure that I actually started to really enjoy working with physics, and then in particular space science, space technology, and like I suppose the other thing that I think binds all people who are into astronomy and astrophotography is probably, you know, the fundamental questions about the universe that we live in. And I think that's what really drove me into enjoying astronomy as a hobby.
Yes.
Because, and I suppose, not to make it too complicated, but it comes back to light pollution in the end. Like where I grew up, we had no night sky to look at. Like maybe you'd see a few dots.
Yeah.
So I never really had a night sky to inspire me. And then it wasn't until I actually studied physics with astronomy that I actually learned about all the cool things that are up there. So that's really then what started the passion for me as well.
So light pollution is it's the bane of my existence and many other astronomers, non-astronomers, animals, insects, you name it. What made you start looking into light pollution specifically? Like out of all the things that you can study and work in or work towards, what was it that drew you towards light pollution?
Well, I suppose when I was in college is when I started acquiring astrophotography equipment to do it on my own. Like I bought a broken mount, some badly column-hated Newtonian and things like that. It was missing parts. And obviously in college, you don't have a ton of money to spend on astrophotography. So I was just it took me a couple of years to repair that stuff. And
you kind of figured out how it all worked and everything as you repaired it?
Yeah, exactly. Like I had disassembled the mount and reassembled it and figured out what drivers we needed to connect to different COM ports. And there was a specific driver that needed a CD installed to a specific adapter. There was just a lot of like small things like that. And it was only kind of after I'd finished college and my PhD then that I actually started using that equipment and doing astrophotography. And I got my first images that were really cool. Obviously, I imaged Orion, and it was cool. I got to see the nebula, and I was like, wow, I've been studying this stuff for my whole career, and I finally just done it myself. I finally just did the astronomy, and it was like such a cool moment. And then it was very quickly I realized, wow, I've waited all this time and I've processed the data, and I had realized how much the light pollution was impacting the image. So I started looking on the market for light pollution filters, and I just didn't like any of them.
Yeah, that's understandable.
And at the same time, I'd been working in a company doing optical engineering for like 2 years at the time, and I had made a bunch of these tin film filters for different internal instruments we had. So I was like, well, I know how they're made. I know the suppliers. I know the manufacturers. I know what drives the cost. I've made 20 of them. Why don't I make one for myself?
Yeah,
and that's why. that's
it's so great and so like grassroots and organic, right? Solving for a problem that you had. You're already working for the company. Why not give it a shot, right?
Yeah. Well, I didn't actually do it while I was working with the company is the other thing. It just happened to be a bit serendipitous with what was happening in my life. So I was working in Galway at the time, and at the time, me and my wife were thinking we'd move back to Dublin, and the company wasn't keen on, having me work remotely. So it was just serendipitous that I wanted to do this filter. I'd wanted to work independently and have my own business for a long time. So, that's it. The timing just worked out that I could just go and do it.
That's so cool, man. I love that.
Yeah. So one of the reasons that I really wanted to do the filter is that if you look at the measured light pollution from different cities, a lot of people say now we only have to worry about LED, which is largely the case. Like LED is the biggest problem we have at the minute, but there's also most, communities, like the local councils, probably not all of them have upgraded from sodium.
My neighborhood's sodium, 100%.
Yeah, not all of. Then there was CFL, compact fluorescent, and then there's metal halide. So, in fact, the light pollution spectrum is not just LED. It's actually it's a complex mix of all of these. Yes. And if you look at measured spectrum from a bunch of different cities, you can see that, and each city has a different mix
Makes sense, right? Because
Yeah.
no city's exactly the same. Everybody's using different technology and different finances, depending on if you're a rich city or a, less rich city, then you might have older lights or newer lights.
Yeah, exactly. So what I did then was I took a lot of these measured spectrum and I looked at the manufacturer data for the lights as well, and I overplotted them on some of the available filters on the market. And it was from that I could say, okay, well, they have part of their band where there's a really strong source of light pollution, so I don't want to buy that filter.
Mm-hmm.
And I just did that with basically all of them to the point where I realized, well, the filter I want isn't there.
Oh, man. That's familiar.
Yeah. I think it's the same with a lot of the guests that you have on here, where they want to do this thing in astronomy, but they realize the exact thing they want doesn't exist, so they go and make it.
That's why the show exists, and so every guest tells that story in one way or another. I love it. So what was it like? What was it like to actually prototype that first device? Like, how much trial and error did you go through? Or
when it comes to the filter, there was zero trial and error.
Okay.
It was 100% had to be right the first time, because it's too expensive to make one.
Yeah.
The cost of making one is the same as making 50 or 200, depending on the size of the.
Because of I would assume forgive me, I'm a layman, but the science behind it kind of dictates that it would be It's like making what do they call them? Like plates for T-shirts. You wouldn't just make one T-shirt with that plate. You got to make 1,000 of them for it to make any sense, because you put all the work into the filter. Yeah. Okay, cool. So what's that like? What's the process like then for figuring out how to make it?
Well, there's so many aspects to it. So like, let's say, I was telling you I got all this data from measured light pollution spectrums and manufacturer spectrums and overplotted it. And I decided where I would like the bands to be, how I would like the bands to be. And what these filters are, they're thin layer stacks of dielectric metallic materials, and each layer is sometimes like a quarter of a wavelength.
A quarter of a wavelength. I was reading about this last night because I wanted to do a little bit of research about how filters work, so I didn't sound like a complete idiot, but explain what that means. What is a quarter wave thickness? A quarter light wave?
Yeah. So if your normal 550 nanometers, think a quarter of that. So
wow.
Yeah. So sometimes the layers are 30 to 50 or 100 nanometers, sometimes less, depending on the waves.
Yeah.
The wavelengths of interest. So let's say you agree your specification for the coating. What you can do, you can use a software called Essential McCloud.
Okay.
Or there's a number of softwares that can do it. And by rights, you can do it with pen and paper, but like in the modern age, people are using software.
Of course.
So you make these quarter layer stacks using your typically at least two dielectric materials. Sometimes it can be more complex. So typical combinations or materials would be magnesium fluoride or titanium dioxide or silicon dioxide.
Okay.
So they could be the materials that are in your quarter layer stack.
Okay.
And you just build that up depending on the specification of the band. So you can optimize it with software. So where you want the band to cut on and where you want the band to cut off, which bands you want to be blocking, which bands you want to be transmitting. Sometimes you might combine a short wave pass with a long wave pass filter. And, that's how you would build up a band pass filter.
Yeah.
But I can do that, and I have done that. But one thing I learned from working in the other companies is there's no real point in designing your own quarter layer stack, because when you go to your manufacturers, their coding engineer is going to want to design their own stack depending on the manufacturing process that they have, on the requirements of the machines that they have, and the experience they have with their process. So that's how it's done, but by rights, that's actually done with the coding manufacturer.
So these coatings and the quarter wavelengths, as you say, do they sequentially subtract the light that you don't want as it passes through the filter? is that how this works, or is it blocking it all out from the get-go and only letting through like that like the HA signal, for example? Like, I've always wondered, like, because you look at a filter and you just see like, ooh, shiny, clear, maybe a specific color, right? But is it a process where it slowly narrows it down to what you want, or is it kind of all of the lights going through at once? And in other words, would the top of the part of glass be the same as the bottom part of the glass?
It happens as a function of the thickness of the layers. So the closer you want it to be to your design specification, it's probably going to have more layers. So the more relaxed your specification can be, the less layers it can have.
Okay.
But the more layers it has, the more transmission you get, the more out-of-band blocking you get. But then also the cost rises dramatically because non-uniformities as a function of all the layers is going to impact. So that's one of the
balancing act then.
It's a balancing act. Yeah. And with the Spectral Pro in particular, this is like one of the ways that it has high transmission and has high out-of-band blocking is a high number of layers compared to other filters. And it takes a long time. So this particular filter, the engineers worked overnight in the factory to manufacture it, which they don't normally do. They don't usually work with that number of layers.
Yeah. So you're saying workers usually don't like staying at their jobs all night long?
No.
But you got them too, though, and they actually did build it out the way that you had envisioned.
Yeah. So to be clear, like I'm talking from Leviathan Optical Engineering, but I've worked with a company called Delta Tin Film in Denmark to get it made, and I'm essentially a one-man startup at the minute.
Of course.
So I have to.
Yeah, I mean, you have to work with people, especially in this day and age.
Yeah,
I couldn't even imagine how you'd begin.
The machine to make it is absolutely incredible and cost multiple millions to make. So this is.
I bet.
Yeah. So the specific type of process is called magnetron sputtering. So that's a type of PVD, physical vapor deposition. So that's actually the process of how those thin layers actually get onto your substrate.
That's what I was wondering. That was you're reading my mind through vapors. So they're literally vaporizing the materials and then slowly kind of stacking them on top of each other, and they solidify.
Yeah. So there's a bunch of different ways of doing it. So like the most standard way is like, you have your materials, like for example, titanium dioxide in a tungsten crucible.
Okay.
They're all of the processes usually have a vacuum chamber where you vacuum out the atmosphere, but you'll always pump in a gas like argon.
Mm-hmm.
But then you heat your crucible, for example, with your titanium dioxide, and it essentially vaporizes and lands on your substrate and forms the layer. But what you have to do is make sure that the layer is uniform and the right thickness. And that's what's hard, especially as the layers get thicker. This specific filter is made on a magnetron sputterer, so it's slightly different, where there's magnetic field involved in the target. So there's magnets, and then you have your target. And actually, similar to what we were talking about with the Van Allen belt, there's going to be electrons passing over the magnetic fields inside this target. And as the argon comes in, there's a physical interaction. An atom's going to hit the target, and then atoms of that target, for example, if it's silicon dioxide in this case, will land on your substrate.
Wow. That is so cool.
It's a really cool process. It's a really cool process.
At the end of the day, do I have this right? So different materials cut down, well, I'm saying cut down, but layered in different thicknesses absorb various lengths of light. Is that a correct way of saying it?
Yeah, I'd more so say that like the quarter layer stack is selecting what gets transmitted and what should be reflected back.
Gotcha.
Some of course will be absorbed, but typically we want to minimize the absorption.
And that's where you get the higher transmission rate, and that's why the balancing act that we talked about is so important, because you want that higher transmission rate. And
yes.
Gotcha.
And,
okay.
And most importantly, it's like you want the highest amount of transmission where you want it, and the highest amount of blocking where you want it.
Well, let's talk about what the results are. So what did you think when you first held it in your hand? Was it like everything that you had hoped for? Because I would imagine this, quite a goal in life to accomplish, to actually create your own light pollution filter. And not only that, but like know the physics behind it and how it actually works. That's pretty freaking incredible. So
I was terrified. I was afraid to touch it.
I bet you were, man. I was afraid to touch it the first time I opened it up.
Yeah. Honestly, I had them for quite a while. It took me a while to actually open the box. I was like really afraid because like this is like one of the hard parts as well, as the cleanliness. Like you have to be so clean when they're made, and then clean when you're packaging them as well.
You have to take care of them. It's absolutely crucial. I'm always
so I have to be very careful when I have to be very careful with each one I open.
So I can't even remember how we started talking originally. I don't know if you messaged me or I messaged you, but we got to chatting and you had completed the filter and you were like, do you want to try it out? And
yeah, I had, because I started listening to your show right about the time I started this business. So as soon as it was ready, I was like, well, he has to have one.
I love it. And me living where I do, I constantly battle light pollution, and it's like the bane of my existence here. And like I said earlier, and everybody who listens to the show knows, I absolutely hate light pollution. And I try to educate everyone that I run into about why it's such a problem. But the reality is like, if we want to do this hobby from our suburban homes, in 90% of the cases for people living in America, and I'm sure in Ireland as well, like we're going to have to deal with light pollution a lot of the time. And up until me and you talked, the best that I had used was an L-Pro filter, and like, credit to Ioptron, like I hadn't seen anything else. So whenever I got the results, I was like, wow, that's really good compared to not having a light pollution filter. But it wasn't until I actually used the Leviathan that I saw like how much better it could be. And like, I haven't gotten to record a lot with it yet because I started actually using it towards the tail end of nebula season last year, and for reasons I won't even get into, this winter has been awful for the most part in North Carolina, and now we're finally starting to get some clear skies again, but it's galaxy season now, so like I'm over here just licking my chops waiting for May and June to roll around so I can start actually hitting some more nebula targets. But I did do a really cool version of the Heart Nebula, and what was great about that, it came out so good, man. And it wasn't a ton of integration time. I think I did like, it was 6 to 8 hours or something. It was a pretty brief, a one-nighter, I will say, for a target. And I had done that exact same photo with the L-Pro because I've shot in the Heart Nebula so many times. So it was so easy for me to look at the final product and be like, holy crap. And I even had somebody comment, like, why even bother with mono and, LRGB SHO filters if you can get this level of quality from a one-shot color camera? And for me, that kind of says it all, because like I'm a big fan of one-shot color. I still don't own a mono camera, and I'm not planning on purchasing one anytime soon, just because I really do enjoy one-shot color. And like, I know the benefits of mono. I get it. But like, I don't know. I can't picture myself going through all these different filters to get one final data set. And I don't know, maybe that'll change in the future at some point. But as things stand right now, I prefer just using my one-shot color camera. So like, once I was able to do that and then see the frankly ridiculous results that I got on the Heart and like the stars, like that was one thing I immediately noticed was the stars on the L Pro. They get so blown out with halos and artifacts, and I mean, the nebulosity looks good, but the stars, they don't look great. They leave a lot to be desired, and it's not as crisp is the best way I can put it. But man, hats off to you. You've definitely made a quality filter.
Oh, thank you. I'm glad you said all that. But yeah, like you actually got an image with it before I did. And the other tester I have who's doing a lot of testing is John Walsh, who he lives quite near me. You both gave me results like that very early on. And the thing that both of you surprised me with was how well it performs on emission targets, because I had designed it to be, like a general all-purpose filter, and then what you were telling me and what John Walsh was telling me is that even on a target you'd usually use a dual narrowband for, this was working better, and I was like, wow, that's really cool. And so that was really cool. So like, just to go back, why I think that might be is one of the reasons I make the filter is because when I've made them before, when you ask for a specification at the manufacturer, how much transmission do you ask them for?
I mean, most
you're going to ask for 100%, right?
Yeah, I mean, you're going to want as high as you can possibly get, of course, but you generally don't see anything near that with the results.
Yeah.
So,
but so here's the thing with these filters: when you specify them when the manufacturer, there's always, even in the design, you might be limited to something like 98% or 95%.
Mm-hmm.
That can go up with the more layers. But then there's the yield. How close can you get to that after the manufacturing? So this is something like in my last job we cared a lot about in laser communications.
Mm-hmm.
Because that mattered to the link budget, how much like data is getting transmitted. Like
an extra percentage point is a huge in the grand scheme.
And if you can get that through a filter, if you can get an extra % through a filter, that might be cheaper than upgrading a photonic circuit in your sensors. So you're always talking about your link budget in like cost per dB of data. So it's the sorry, Rio, I got a bit lost about the point I was trying to make there.
No,
but anyway,
you're fine. You're fine. What's a dB? Is that
decibel?
Decibel. Okay. Oh, yeah, I know decibels. Though I used to do decibel drag racing here in North Carolina.
Really?
So back in the 90s, in the States, there was this big community around subwoofers in cars. I don't know if you guys had any of that going on in Dublin, but we would basically try to see.
It was called the max power scene, where people would modify their cars.
Man. And it's literally why I'm almost deaf in my left ear and don't got too much in my right. I listened to way too much loud music when I was younger, so I definitely know DBs. I know them all too well. But yeah, man, the test results, they've been phenomenal, man. And I
remember the point I was trying to make. It's like, so the one of the reasons I wanted to make the filter was that the ones I seen advertised, they would just write peak transmission, maybe 90% or 95%, but they never specified is that
the real world,
the max that the design will allow, or is it what they measure?
Okay, so this is basically what they measured in the lab versus what you can actually expect in the real world?
Yes, exactly.
Okay.
So and for a lot of the filters, that wasn't clear to me, so I didn't want to buy them. I wouldn't mind if they said 95%. If they said, okay, the optimal you could get is 95, but most are getting 90, I'd be like, cool. But like, that was never clear, and I want to know what I'm getting.
Of course.
So that's one of the things that I'm doing with the Spectral Pro is like everything you see in the data sheet and everything you see published isn't the ideal numbers. These are measured values that apply to every single sample that everybould going to get.
Wow. And that's a huge difference, because when I say 90 transmission rate?
When I say 98% at this band, that's what we measure in the spectrometers.
Means 98%.
And when I say 95% at F2, I've tested the filter at F2 in the spectrometer, and we get 95%.
Wow, that's impressive, because I know that's not easy to do. So that must speak to the quality of the optics themselves, then, in a lot of ways, right? Just the manufacturing process.
And the engineers that made it, because one of the ways that they're able to get such a high number of layers in their machine is what most of these physical vapor deposition machines don't have is an in situ spectrometer. So usually there's an electronic device which you can measure the mass that gets onto a certain sensor, and that's how you know the thickness going onto it. But what their machine does at Delta, they have an in situ spectrometer, so they're actually able to take a spectral measurement during the deposition process.
Okay.
So that's one of the ways that they're able to get a high number of uniform layers and ultimately get to the end process. And what it also allows them to do is tune the process as a function of each layer.
So not only can they get it right, but then they can also tune it on top to get it exactly where you want it to be, essentially.
Yeah. So basically, after they were made, we measured nearly all of them in the batch, and there's less than like 0.1% band shift between them all, and they're all within like 98 point. I can't remember the exact number of decibels, but they're all 98.9999 something percent. Like
that is cool.
They all match. The uniformity is exceptional.
You're absolutely right too, because I was looking here online, just like glancing at some of the numbers, and you're right, they don't actually give you those results at all on really any of these filters, because I guess most people, I think most people do know to ask something like this, especially in the hobby that we're in, and with how much you got to pay for a good set of filters. You definitely want to know what you're getting.
Yeah, like especially when people go to mono filters, you can spend multiple thousands.
Yeah, easily. I was actually looking at filters yesterday because I'm trying to. I got a 5 filter bay for my color camera, actually, because I'm gonna put a few things in there, like a dark filter. I'm gonna test your filter. I'm gonna use a dual narrowband filter, and I'm just looking at different filters, and it's great. Like, not only have filters always been expensive, but they've gotten more expensive, like since I started buying filters a few years ago. And not for nothing, but if you're like me and you're a one-shot color photographer and you're considering getting into mono, don't forget to factor in those costs for filters, because an LRGB SHO set from a quality company that is going to set you back, usually at least a couple $1,000s minimum. And that's why, even though it is by one-shot color camera specs, kind of what you would say is an expensive filter, if you start comparing it to things like LRGB show and then looking at the actual results, which is what matters to me at the end of the day, it's actually a pretty damn good deal when you consider that.
I think so as well, and especially when you talk to people who have very bad experiences with other filters. Like, one thing, I've spoken to people about is, especially with dual narrowbands for some reason, I've spoken to a lot of retailers recently, and they all complain about the number of returns they have to do with dual narrowbands.
Mm-hmm.
Because when customers try them, a lot of customers don't get great results.
I've seen that too. It's almost like binning CPUs with dual narrowband filters. You might get a great one, you might not. And I would imagine that they are not expecting the tightest tolerances when these filters are manufactured. I mean, who knows what you're getting, to be honest. I'm not saying that for all filters, but for some, I think that is fair to say about. Because I've seen the exact same thing. You go on cloudy nights and start looking through forums about people having different results with different filters, where I say I might love one filter, somebody else might absolutely hate it because they're getting giant halos on everything that comes.
And there you go. One person might have a great one and one person might have a terrible one.
Exactly.
And if you look at some of the measurements that some people have, if you look at where the hydrogen alpha line is compared to their bandpass, it can miss it completely. And you could be getting like less than 50% transmission in some cases. And then it gets worse as you go to off axis, right?
Uh-huh. Yeah.
So then if you've got a fast telescope, then some rays are going to be getting, some parts of your field are going to be getting essentially 0%.
Oh man, that's awful. But yeah, I mean, you're absolutely right. That is definitely a real possibility. So, all right, welcome back to the Astrocast. We are sitting down with James from Leviathan Optical today, talking all things filter, and we just finished talking up about kind of the process behind building one of these filters and what all goes into it. What other sort of unexpected results did you get from the filter? Like, did anyone, like your other buddy who's doing testing for you, did you get anything that you didn't really expect to hear from him when he started giving you feedback?
Like what I was saying about the hydrogen alpha and dual narrowband, like emission targets. I think everybody who's used it has been quite surprised that it can work well, where you'd usually use a dual narrowband.
Mm-hmm.
But one of the other things that John Walsh really likes about it is that some of the images he's gotten, and you can see them in the gallery, he likes it when the like hydrogen alpha fields. He likes the complex targets that have hydrogen alpha with a reflection nebula, so you can just image with one filter and bring out a reflection nebula and, for example, a hydrogen alpha and the things like that. So you can see he does that. There's one in the Cygnus area, and then he does it. Yeah, you see this one, VDB 132.
Yeah, that's gorgeous.
So he got that with a DSLR. He got that with a DSLR as well. With a
DSLR, you got that?
Yeah, John Walsh is incredibly talented. Like, he gets absolutely fantastic images with often modest gear, and you'd not even tell, like, at some of the images when he's upgraded to the 2600 later.
That's awesome.
Yeah.
You know, so really the majority talented astrophotographer when that's the case. Man, look at the wow! Look at the popping on Andromeda here. Wow, that is cool.
Yeah. So that's the other thing is people generally like seeing the hydrogen alpha come through when they do galaxies with it.
Definitely.
Especially, M81, M82, the cigar galaxy, when you have that the jets coming out of M82. And there's yours.
There's my picture. I love it.
Yeah.
And look at the O3 coming through too. Like, and I guess this kind of speaks to what you're saying, because when I processed this image, I actually did split it out and PixInsight and try to isolate all of the channels, and it did a pretty good job of it, I think. I mean, all things considered. And
by the way, I have that script for PixInsight.
Yeah. You were going to give me a script to pull out a specific line, right?
I have an updated one, so it should work a bit better now.
Okay, great. I'll definitely run it through that. I actually got everything set up in here now, so it'll only take me 2 seconds to do it. So, man, what a beautiful, beautiful version of the dumbbell.
I know, and if you compare that like on Astrobin to like other images for similar integration times and light pollutions, it's a fantastic result he got there.
And it's so clear too, because usually, like, frankly, I was gonna say, when I do the dumbbell, a lot of times, and I don't think I've shot it with this filter yet, but it's usually fuzzy around the outside. But this is so clearly visualized. I love it. Is that the Cocoon? Okay.
Yeah, so the Cocoon, that's another good one as well, because there's reflection elements in it as well.
Oh man, and all the dark nebulosity in the area too. That is
so the width of the bands help with the dark nebulosity there.
Is that a fact?
Yeah.
Because this is something that I'm really hoping to get into now that I'm going to have access to some darker skies. That was what the first thing I did when we went to Wisconsin for First Light last year. I picked my first dark nebula target to shoot, which was the Dark Shark Nebula.
Oh, that's exciting.
And man, it was so beautiful. And like, there's a whole world of targets out there to explore for people who, if you've only been shooting like a Mission Nebula for the most part, or the more popular targets that we all see, on any of the social media sites or Astrobin or what have you, the Dark Nebula is just such a really cool thing to explore. And I see that it works quite well with the Leviathans. That's good to see. The Spectral Pro.
Well, so there is a nuance to that. So a lot of the dust that people like to see often has that kind of brownish color, right?
Yes, it does.
That is the same wavelength as the peak of the LED spectrum. So that is actually blocked by the Leviathan Spectral Pro. But if you know, the bands are 30 33, 32, and 13 nanometers. So they're left a little wide on purpose to help with, like, you know, the dust broadband features, but you're never going to, with this filter, you're never going to get perfect dust with it. It's one of the trade-offs you have to make if you're in heavy light pollution and picking your filter.
Is that why you were asking me about my Pleiades image with the dust on it? Because I did 45 hours on the Pleiades with the Leviathan, and the dust came out like really, really, really good. I still want to shoot this target again because it's so challenging when you do try to get, the dust, frankly, around the Pleiades. But when you can nail it, here, let me see if I can share this with you. I don't know if you could see that or not. Here, hang on, let me click share.
I think what we were talking about then was that some of the brighter stars had a halo on it. And and we were trying to really come to the bottom if it was the Spectral Pro or from your optics or coma corrector.
Right about that.
Yeah.
Here we go. This is the one. The Pleiades. This was 45 hours.
Wait, so was that all with the Spectral Pro?
That was 100% with the Spectral Pro.
Really? And all that dust came through?
Yeah, man.
Wow.
That's what I'm saying. So you must have got it.
I need to look at that again. All right, take back what I said there.
And look, I will be clear on this. Like, it's an incredible image, but I did think it would come out a little bit different at 45 hours because I've seen some images and I don't know if I like it more. That's why I couldn't compute this picture, because some of the pictures I see of the Pleiades with really long exposure times, it's just like blanketed in dust, and it's almost like, am I seeing the same thing here? It's interesting, and I don't know what to make of it because everything looks so well defined in here. You see what I mean? So I don't know if maybe I really don't know. I don't know the physics behind that, but I will tell you it's a gorgeous image. It definitely came out quite well. This is one of my favorite ones of the Pleiades.
Yeah, honestly, I assumed you had added some broadband to that to get the dust out. This was that's really cool
with the Leviathan. So yeah, it came out good. Oh man, wow. So
I need to spend some more time looking at that and admiring that.
I'll send a copy of it over to you.
Yeah, I have it. I just need to.
Okay, cool.
Yeah. I just need to admire it some more as well.
Oh man, I never. We're our own worst critics, aren't we? I'll put down a photo for 3 months, and then it'll pop up on my screensaver, and I'll be like, oh man, look at that, it's gorgeous. And
you need time away. You need time away when you're editing.
You definitely do, because you stare at it for 6 hours while you're in PixInsight getting every detail just right. So what's next, man? Now that you've got the filter in hand and you've got a few out in the wild, what are you hoping to do next with the company?
So really what I want to do next is get retailers to sell the filter on my behalf. So I have one retailer who has it available on his site. That's Horizon Astronomy. He was based in Ireland, but he has moved his company to Munich in Germany. Okay. And it's interesting. The reason he's moved his company is one of the problems. It's not one of the problems, but one of the annoying things is that shipping from Ireland is unusually expensive. Like for similar products, if you're shipping, let's say, a telescope from France to Germany, you might spend, just as a reference example that I was talking about with some other people in the industry, it could be 20 or 30 euro, but shipping the same thing to and from Ireland, you're talking at least 60 to 70 euro.
Oh, wow. So significantly more, Yeah,
it's significantly more. So this is one of the reasons I'm hoping that when retailers have it, they'll have more efficient supply chains. So I'm hoping that it actually becomes cheaper for the end user to buy from the retailers.
I also think that if you can I think one of the things that's really key to this filter success is getting the documentation in front of people that really read over things thoroughly. Because if you're like me, you do a lot of research before you pull the trigger on something. And it's good to be able to really pore over the details. And I know that you've got the details in spades. So if you could get that up on like a High Point Scientific or a Gina Astro and have, all the documentation showing the specific, wavelengths that come through and, test cases, use cases, et cetera, I think that would work very, very well for you.
Well, look, here's the thing. That's what I assumed too. And I think that works for a lot of the people. I think for people who are like very technically minded and online quite a lot, who are used to buying things online by spec sheets, that works really well. So that's why I have my data sheet up there with just like all the measurements and field testing examples. That's why I put it up there, assuming everyone's like that. But one thing I learned from being at the Astrofest in the UK is actually that's not actually what a lot of people want. A lot of people want a sales pitch. And
that's tricky.
so I was at the table. I was like, I have this. I was trying to show people. I have a data sheet here. Here's all the measurements. You make your own mind up. And they're like, no, you tell me why it's good.
No. You're right, though, man. There's a lot of that in the world. You know,
but there's nothing wrong with that. It's just some people take in information in different ways.
Yeah, definitely. So have you come up with a sales pitch yet? Like, have you got your 60-second elevator, or are you handing the sheet and say, make up your mind? Because you're going to have to bend at some point.
Oh, well, if they asked for it, I gave it, you know.
Yeah.
It's more or less what we've been talking about, but in 30 seconds.
Exactly.
It just depends on the conversation.
Yeah.
Honestly, like when that was happening, I just talked to people, find out
it's gotta be tough,
where they're imaging from, what equipment they use, and I just try to talk to them and see if I try to see if it actually would be useful for them, because some people it is and some people it isn't.
Yeah. I mean that's fair. I'm trying to see it from your shoes, and I'm like, you understand all the work that goes into getting levels like that, and I bet you're really proud. It's like, nah, here you go, look, see for yourself. Here's the proof, you know. And then, well, tell me why it's better. It's like, no, it's right here. People don't want to hear that, though. Not in this day and age. They need to know in 30 seconds why it's the best thing ever.
But not everyone's technically minded either.
Yeah, no, absolutely. And
but the other thing, nobody wants to read a PDF in front of the person who made it, right?
Yep. This is true as well. Yeah. And we are seeing like I'm not going to say a grand shift, but we're definitely seeing a shift toward a lot easier astrophotography. I mean, you know, I wonder what the percentage of astrophotographers is out there now that literally just set down a smart scope in their driveway and walk back inside and, you know, tap tonight's best on the ASI Air app or what have you. And
it won't be long until it's the majority. It won't be long until it's the majority. Well, who have one at least. I think it's like a great way for people to get into the hobby.
It is.
Like how better to do it, because like the hardest part of it is like setting this equipment up.
Do you worry though that something is lost in the hobby? I don't know if I'm being a snob. Like, this is something I've struggled with for so long, and I've come around on smart telescopes a lot. I understand their value that they bring, and I also understand that, like, hey, look, if somebody gets their foot in the door and it gets them interested in the night sky, I don't care how they do it. That's awesome, you know. And I've come around on that, but like, I don't know. Maybe it's just my personal experience, because I've only seen the world through my own eyes. But learning like how all this gear worked, like spending countless nights, you know, setting up, breaking down, and like learning the constellations and learning azimuth and altitude and the meridian and just like all these things that like are permanently etched in my brain now. I worry that like the person with the C-Star S30, if I say, you know, oh, well, you know, just look at Cygnus and wait for it to cross the meridian, they're just going to stare at me like, huh? What are you talking about? You know? And, but then again, maybe it's just a starting place, and I just started from a different starting place than they did, and we all get to the same place at the end.
A strange analog is in mountain biking. When I first started mountain biking, everybody's bike was a pedal bike. Right, and now nearly every bike you see out in the hills on the mountains are e-bikes.
That's crazy. So it's like that on the actual mountains too. E-bikes.
Yeah, with pedal assist with batteries and motors.
Do you have one, or do you still have a pedal-only bike?
I'm pedal-only at the minute.
That would be me if I was. I BMX biked a lot when I was younger. Believe it or not.
Oh, cool. Yeah.
I loved BMX biking, man, in the 90s. Oh, God, I loved it. I could go on about it all day.
What a time to be alive.
Yeah, it was special, man. It really was. Yeah. But yeah, I guess so, huh? E-bikes on the mountain slopes and falls.
But I suppose when it comes to astronomy, it levels the playing field, like in a way.
That's true.
Like it does get more people into it. It gets people into it who wouldn't have gotten into it otherwise.
Absolutely.
Which you have to say is always a good thing. And like with the e-bikes, it got people into mountain biking who were maybe intimidated by it before. They always wanted to do it, but they were afraid, because going from being a couch potato to mountain biking is actually quite hard. It's hard to pedal a mountain bike up a mountain. It's
not only is it physically, it's hard to go up a street with a hill on a regular bike. I can't imagine pedaling up a mountain. Like,
so it gets people into it, and some people then get into the hobby in different ways.
This is true.
I think for people maybe like you and me, like I love the equipment. I love picking and choosing, mixing things up, changing lenses, changing telescopes, working on mounts. I like that part of it. I like the hardware.
The tinkering and the hardware. That's definitely me.
I like getting the stuff working. The image that comes at the end is nice too, but
there it is.
Oh, beautiful!
I'm working on my.
That's a nice rig.
Yeah. I've been working on that one a lot. That's the one that's going to head out.
It's nice when it looks good as well.
Yeah, when all the cords aren't on it. Whoever invents the cordless, like full rig telescope is going to make a whole lot of money, because man, they look cool before you plug in USB cords and have them hanging all over the place.
Or you could just get a smart scope.
Yeah, there you go. Just one USB-C cord. Oh wait, you don't even need that, because it's got a battery built into it. Go figure. So James, tell me about, you mentioned earlier that you were able to image with the filter at f2, correct?
Yeah.
So that's a pretty big deal, if I understand correctly, because I remember when I was looking for my first like dual narrowband filter, that I saw ones that were made for kind of your regular telescopes, like, your f5 type normal refractors, but then they also had special versions that were made for f2 lenses or scopes, RASAs, those sorts of things. Why is it that some are manufactured differently like that, and what is it about your filter that does not necessarily require it?
That's actually quite a complex question, and it's a simple question at the same time. So why does f2 matter? It's because that the performance of the filter is dependent on the angle of incidence. So if you imagine just taking any lens, any telescope, and your sensor, light rays, because when we talk in terms of optical engineering, we talk about light in terms of rays, coming from if you're pointed directly at a star.
Yep.
Those rays are completely on axis with 0 degrees angle of incidence.
Okay.
But if you have a star at the edge of your frame, that's coming in with an angle of incidence. So the larger that angle is, the more the band shifts.
That makes sense. Blue shifts, yes.
Yeah. So potentially, let's say if you did not consider the angle of incidence in your filter design and specifications, you would have rays from different parts of your field of view, either potentially just getting completely blocked by the filter instead of transmitted, especially if you think in terms of like monochromatic emission lines like hydrogen alpha.
Okay.
So rays, the filter will affect rays differently depending on the angle of incidence. It's basically it. So how some filters get around that, and how the Leviathan does it is in two ways. One is that if you make your bands wider and shift them by a few nanometers to the right, then you have a budget. But the other thing is you can actually you can desensitize the effect of angle of incidence in the layer stack. So that's one of the things we talked about with the designer. I put it in the specifications, and that's one of the things we talked about. They suggest we can move it a few nanometers here.
I'm picturing light rays coming in, right?
Yeah.
They're coming in like this, and then I've got this cup that I can catch the light rays with. And if I widen my bandpass, then I can catch more of the light as it's coming in. But if I make it more narrow or faster, then it is harder to catch those same band passes. Am I?
Yes.
Okay, that makes sense. What is it that determines the angle of incidence exactly? Like, is that a result of manufacturing, or is that something that you go into manufacturing saying, I'm trying to hit this angle of incidence? Like, I don't know if it's a byproduct of how the filter is made, or if it's something that you actually designed for to say, I want to be able to hit at least this angle of incidence whenever I'm imaging.
So in principle, it's two ways. So I knew that the angle of incidence I was working with, was because a lot of the telescopes are f2. So I made that the specification we were aiming for. So
okay.
We talked about it a bit earlier, but one way you can do is just make the band wider.
Yeah.
But the other way is in the design of the stack. You can design in a desensitivity to the band shift.
Oh, okay.
So there's two ways to do it like that.
That is so fascinating because I see these pictures of wavelengths always for, what a filter allows through and what it doesn't, but it never actually occurred to me, how that works and why, frankly, a narrower bandpass might be a bad thing in a lot of cases, especially if your tolerances aren't exactly spot on. And I would imagine, sure, they're expensive for us, mere mortals, but you're not talking like scientific grade when you buy, some of these filters off some of these websites, and I'm not going to name names or anything like that. But there's
to be honest,
ones out there.
A lot of hobbyists do have professional grade equipment.
Oh, I'm sure they do.
Yeah.
I guess what I'm getting at is if you want professional grade equipment, it is out there if you know where to look, and it is affordable within a mere mortal's lifetime.
Yeah.
You just have to know what you're getting, like you say. And to your point earlier, like you want to know what you're getting if you're purchasing a filter and actually know that the data backs it up, because otherwise, like, how would you know? Like if you were an astrophotographer who was, let's say, a solo astrophotographer who didn't have a club nearby, and you learned the hobby during the pandemic, and you've been taking images of the night sky for a long time, like you wouldn't know that you're missing out on 50% of your possible signal if you never knew that it was there in the first place. Does that make sense? Like,
yeah.
You would just assume, that's what the filter does.
Well, I suppose that also tells you how important it is to be part of a community and to be able to show people your images, and some might go, maybe your image should be better, maybe there's something wrong with your part of your equipment.
Thank God we have Justin in our group, because he can point out a flaw like instantly. He knows it, man. It's funny because
the amount of knowledge and experience from the vast amount of data he has is absolutely mind blowing. When you first started, when that one was posted, I looked at the title and I almost didn't listen to it because I was like, there's no way I'm going to listen to people talk about data for as many hours as it was. Or whatever it was. And then within a few seconds I was hooked. Like my jaw was dropping like that for the whole time I was listening.
Man, I love that so much, because that's exactly how I felt when I was recording it.
Yeah,
Anytime,
I was just in awe.
There's something special about getting like-minded individuals together and talking about something that you love, man. You can just hear the excitement in people's voices, and that's one of the reasons I love doing interviews for the show, and I've been trying to do more of them this year. So, I heard you mention the European Astro Forum that you attended. Are you ever planning on coming to NEAF by chance?
I really wanted to, but I just couldn't make it work in the budget at the time and getting the right amount of time off to do it. So that's why I went to the UK Astrofest. It worked out a bit cheaper because the accommodation and flights were very cheap for me. But to be honest, I really wanted to do. That's the one I really wanted to go to. Hopefully next year. That would be great. I suppose the other thing I want to talk about before we wrap up is so I do have to adjust the pricing for the filter soon.
Okay.
But what I'll do, because I know a lot of the other people who come on the talk offer some kind of like discount or offer. What I'll do is I want to keep the free shipping on the filters for let's say 2 or 3 weeks after the podcast airs.
Okay.
So I'll keep that free shipping until
that is
some
awesome.
amount of time after.
And that's very awesome. So thank you for doing that, James. So I guess it kind of goes without saying, but I will definitely put a link to your store in the show notes for this week's episode. So if anyone is interested in actually picking up your own Leviathan Spectral Pro filter, please make sure that you check the links. And I mean, I can just tell you, I've been using mine for, I think I'm coming up on a year this summer, and I've had nothing but phenomenal results out of it. So thank you so much for letting me be a part of your testing process, James. It really means a lot, because you were actually the first person to actually send me something to demo, like for the whole show, you know? Like I had never had anybody actually send me something or say like, hey, Rue, try this out and let me know what you think. You were the first person to do that, man. And that means a lot to me. It really does. So I really, really appreciate you doing that.
Well, no, the pleasure's all mine, because like I was saying, like I started listening to your show at the time I was starting the business, and I was listening to it the whole time. So I felt like, you know, you were starting your podcast at the same time I was starting my business, and I don't know, I just really wanted it to be you who had it.
That's awesome, man. I love that.
So I'm so happy. I'm so happy it took it.
Yeah, well, believe me, I'm thrilled to continue testing it, man, and I'm really excited about this summer season because I'm going to be able to test it so much more. I'm actually building out a new rig for my peer, because I'm going to have the scope out in Utah soon, but I want to be able to image from home still too, because I'm a hands-on guy and I couldn't imagine not ever touching a telescope. That just sounds like hell to me. So more than likely I will continue testing that throughout this Milky Way season. And I haven't done it yet, but I've got plans now. I've been getting some more EF lenses, and I really want to try getting it on like a 50 to 85 millimeter EF lens connected to my astronomy camera with a filter drawer in between, and doing like some ultra wide Milky Way shots, like Olive Row and the Horsehead Nebula and, part of the core. Like I love those shots. And I think the Leviathan would do really well in those circumstances. I just have a feeling that it's going to do great.
Yeah, someone was using it before, and they did use on like a 24 millimeter lens, and they got this amazing. Yeah, they got an absolutely beautiful shot, and he called it a test shot, but I was like blown away.
Oh man, please send me that if you get it, because I want to see it. I'm so pumped, man. I almost woke up at 2:00 in the morning last week to go and see early Milky Way, but I just didn't have the energy. It had been a real long week at work and everything, but I no doubt next new moon I'm going to be going somewhere dark. And when I say dark here, that's Bortle 5, Bortle 4, hour 2 hours drive. And I love bringing out, because the Milky Way, it's so faint. Like I feel like if you're not in Bortle 3 or lower, like it's almost like, why bother?
Yeah. Oh, well, to be clear with this guy, I think he was like Bortle 5 when he took that image. Yeah. But what using any filter in that case is like, it cuts out some light, but it allows you to get more signal of, you say, wavelengths of interest. So like you will bring out,
what you actually want to be in.
You will get some nebulosity with it. So that's one of the things. Like I mentioned, John Walsh. He did a lot of his testing in he's not sure. He tells me it's Bortle 6 or 7, but his process that he prefers, like he actually does a combination of broadband and the Spectral Pro for that.
Okay, so he combines the two. Maybe I'll give that a try next time I do, because my God, man, he's got really beautiful results.
If you look at my website, I put the images with just the Spectral Pro, but then if you look at his AstroBin profile, he's often combining.
I am going to check him out on AstroBin.
Hold on, I'll send you the link.
I was going to say, send me the link, and I can what I can do is I can drop it in the show notes as well, so that way any of the listeners can check it out. And obviously I'm linking to the Leviathan webpage as well, and you can check out my version of the Heart Nebula there, as well as lots of John's photos, including that amazing Andromeda image. I don't know why, man, but I've caught nebula and Andromeda, and there's something incredible about like seeing a nebula in another galaxy that just blows my mind when I see it. And this one really it screams hot. I love that, because you don't see that too often in Andromeda photos.
Yeah, well, have a look at his AstroBin. I just sent you the link there, and you can see the final one he got with Andromeda, where he combined it with just like pure broadband. And then after, check out his Cocoon one versus what's on the Spectral Pro website. So
excellent.
So let's say the more advanced technique, especially if you're in one of these mortal mortal. I meant that middle mortal zones. Often the more advanced technique is maybe to combine it with broadband.
Yeah, I mean, I guess that makes sense. What do you know, like what sort of timing? Because this is the issue I always run into whenever I try to go just full broadband from home, and my Bortle also 6/7, probably closer to 7 now. Is he doing shorter exposures, or does he go? Because I would imagine you'd get blown out if you did 3-minute subs from a Bortle 6 or 7. So you kind of would have to go like 30 seconds, and then does he like do like a blend of them together in post?
I
guess that might be a question for him. To be fair.
I'm looking on Astrobin. It looks like he has done the same exposure on both, but I think it's always worth testing your exposures.
Definitely.
Like if I shoot without a filter, I'm usually blown out at 30 seconds, but with the filter, I need to be at more like 240 seconds.
I have been doing 3-minute subs for as long as I've been doing astrophotography. And unless I'm doing like something weird like Milky Way or what have you, I don't know why I always stick to 3 minutes. Maybe I should try 5-minute subs sometime. Might be worth it.
I have a post on the website, and I'm working on this tool. It's mainly optimized for DSLRs, but I want to get it ready for Astrocam files. But with Nina, and they tell you the statistics and they give you a plot, but it's sometimes hard to read. So I've got this Python script that maybe you'll find it interesting, that it shows you, at least to me, a clear way to decide what your exposure should be.
Oh, okay. So, because I know obviously you can optimize to make sure you're getting the most signal for the given shot without blowing it out, like you say. And does it help you optimize in that way?
It's doing it. If you just drop a few test exposures when you start your imaging session, 30 seconds, 60, 120, 240. Then it takes like 2 seconds to run this script, and it plots them, and it puts a line on the dark current and a line at what the saturation value is. And so what you want to see is that you have a good few hundred pixels of separation from the your dark level.
Yeah, so you have room to push the blacks a little bit, right?
Yeah, and then you want to make sure that you don't have too much separation, and you actually need to look up here to see it better, because it does look like there's a lot clipped here, but it's actually only like a few hundred, for example.
Gotcha.
That are above this level. So in this specific example, I would happily go with the orange or the blue.
Yeah.
But I know for a fact 60 and 30 seconds are too low in this example.
Gotcha. That actually is super helpful, because this would work with a regular mirrorless camera as well, I suppose. Because that's always an issue that I run into whenever I'm shooting with my R5 or my R7, particularly in even somewhat light polluted skies. It's really hard to estimate what time sub I should go with, just based on looking at the back of the screen when the white balance is custom and everything. You know what I mean? It can be difficult to figure it out.
Yeah, so that's what this other blog post is about, basically. It's about this rule of thumb, 1/3 of the histogram.
Yeah.
It's a great rule of thumb, but if you want to go into a bit more depth.
Yes, exactly.
If you want to be sure about what you're doing, you can use a script like this.
I appreciate you sharing that with me, man. I will drop a link to this as well if anyone else is interested, like I am, in making sure that you take the correct length exposures. This can definitely help you do that.
I'm not saying this is the only way to do it.
No, it's not the only way, but it's a good way to do it, and I haven't found a way to do it yet, to be honest.
Lots of tools, lots of the Astro tools have different forms of it.
Yeah.
But some of them do it over 0 to 255 pixels, which isn't actually representative of the sensors that we use.
Gotcha.
Or the bit depth of 255.
Yeah.
So it can be a little misleading. This is just a way that helps me a lot.
I appreciate you sharing that with me, man. Yeah. That's something that I will definitely use.
Yeah, and actually, if you share some M2600 files with me, I can generalize it for those type of cameras. Yeah.
Okay. All right. Cool. Yeah, I can definitely do that. I've got terabytes worth of images. No, I can't believe I built a NAS yet. That's the next thing I really need to do.
Just send me 2 files. I don't want a terabyte.
I want to get 2 terabytes. Don't worry. 2 files it is. Very cool.
My storage situation is not efficient.
Dude, that's me right now. I have stuff everywhere in this garage, and I'm trying so hard to figure out where to put it all.
I mentioned, we were talking about it briefly a while ago, but I have these, I just thought I'd bring it up because you mentioned your wide field.
Uh-huh.
Especially if you're using the Samyang or anything with an M27.
Whoa, what is that?
That's an adapter you can put on front of the Samyang.
Oh, dude, that is awesome. And you can thread the filter right into it?
Yeah.
Wow.
So you can either mount the filter directly into it, or the filter cell itself will thread into it.
Oh, man, that is really cool. When did you start manufacturing those? That had your name printed on it and everything.
And it works with the hood as well.
Oh, that's awesome. That is really cool. And that's a 14? Or is that a 135?
It's a 135.
Nice. All right, cool.
So it's tested with the 135 and it works really well.
Uh-huh.
And this is something that was talked about in your Discord. A lot of people stop down their Samyangs anyway to help with the star shapes. And Justin was explaining, if you stop down with a filter cell,
that is so
it helps with diffraction effects. So that will help.
That's something that I always do with mine, is I stop it down a little bit, because it just, you can instantly see the stars get smaller when you stop those lenses down, because they're just too fast wide open. Night optic.
I did a lot of testing with the filter with this at F2, and it was very annoying having to collect all that data at F2, but being able to see that I had these problems.
Dude, and that
so you really do have to stop it down.
You really do, and not for nothing, but my 135 was completely unusable until I put an M42 adapter on the back, like actually removed the camera flange and put on a proper M42 screw-on thread. And then also I literally had to install an autofocuser. Like I couldn't get proper focus with it. I just couldn't, and it wouldn't hold focus and everything. It was such a pain.
A lot of them you can't get focus on, infinity focus on.
And I had to do the trick that on Nico's channel, where you have to push the infinity further ahead so you can actually get the stars small enough. Like I did that on day one, and I thought to myself when I first got that lens, I was like, why do people love this lens so much? It's like, I don't get it. But then after I got everything properly set up and really dialed in, I started getting some really great results out of it. And then I'm just like, okay, now I get it, I guess. So I'm gonna be using the 135 again this summer. I didn't use it last summer, but I'm planning on using it this summer. So I'm excited about that. Did you 3D print that? What is that though?
No, that's CNC'd.
Oh man, that's beautiful. I was like, that didn't look 3D printed. Is that something you're planning on actually making and selling in the shop?
Yeah, I haven't put them on the website yet, but they're there. I have 10 of them, I think.
Oh man, that's beautiful.
I sold one of them to somebody. I made it for one specific customer because he was interested in it, and I just did a one-off. But if you do the design for one, you may as well get a few. It works out a bit more efficient.
That's cool. If you need to get more cut in the future, can you go back to the same people and have them make more for you?
Yeah.
That's good.
Yeah. Sorry, I'm just showing the page here. This is where I did all the testing. I did test it with 3D prints at first.
Of course.
But look at that. That's a Nikon D750.
Nice.
That's full frame.
That is awesome.
That's just a weird flange adapter I had to test it with. And I'm always testing these adapters to try put in between the lens and the DSLR. Mm-hmm. It doesn't work very well for Nikons because you don't have the back focal distance, but it works well for Canons.
With Canon, you can get 33 with the EF system, I think.
Yeah, and the reason I'm interested in that, I would like to make the Spectral Pro available to Samyang users with Nikon, or any Canon camera, just to do wide field, right?
Yeah.
And obviously this one that I'm showing now, it goes on front, then you need the M48 filter, but I would like that people are able to get the 1.25 inch version in there if they want the filter at a cheaper rate.
Yeah,
absolutely. The downside is that you have a small vignette.
Yeah.
However, what the testing here shows with the vignettes, even at full frame, is that having the filter in front versus in between, it's not a huge difference, actually.
Nah, that's not a huge difference, and nothing that you can't take care of with flats, right?
Yeah.
That's so
and
cool.
then this is the one where that's one where I included both. I put the two on, so that's where just for fun.
That's so cool, man. I love that about solving for a problem that haunts me. I mean, you've listened to all the shows, man. You know how much I love wide field stuff. Like it's my bread and butter, and I feel like there's not enough attention paid to that segment of the market. There's a whole lot of stuff for deep sky. There's a whole lot of stuff for planetary, but you don't see too much for what, like actual wild field astrophotography. Like if you want to use, a 50 millimeter lens and just shoot the entire core, or a 14 or 135s, obviously to a larger extent, but like stuff like this, man, you can make that happen. That is really, really cool. I'm happy to see it.
So I'm certain it works well with the Samyang 135, but it has been tested with the Sigma 24 Art, and you get strange diffraction effects. So I can't recommend it for the Sigma Art 24.
Okay.
If you're going to test it on a few lenses, I could send you one.
You wouldn't mind?
No, absolutely.
Love to test it on a few lenses. So if you want to send me one, I would love that, man. Are you kidding me?
Yeah,
it's almost Milky Way season. Yes.
But the thing about this one is that it's M77 threads.
Okay.
Right.
What's typically M77? That's a lot bigger than what we typically work with. But is that what the size of the front of the 135 can accept?
Yeah, that's the filtering that the 135 accepts.
Gotcha.
It's actually the same thread as the Sigma R24, which is why I tested it on both of those.
Ah, gotcha.
Some lenses are M88. Most typical, kit lenses are like M59 or something.
67.
Yeah, 55.
Yeah. I know that
this one's 58.
The L lenses tend to get bigger and bigger because they got more glass on them, and that's where I've seen the 70 and up. You know what I mean? But most of my like Canon, my Nifty 50 and my 16 millimeter and all those, they're all like pretty small, 55 to 67, somewhere in that range, which always shocks me because I'm like, it's so small, but that's such a good job.
Well, you can always try if you have the right step down rings. You can put the filter cell right in front of your lens,
and
it should work. It should work pretty well, because it's f2.
Enough.
Yeah, because a lot of those lenses are near f2, so it should work well.
Does having the filter cell in front of the front optic in the distance between, does that change how the light interacts? Does that make sense? What I'm saying?
It's dependent on the optical design.
Okay.
So I know it works well with the Sigma or the the 135, but it doesn't work with the Sigma Art.
Yeah.
So it's just to do with the optical design of the lens or the telescope you're using.
Gotcha.
So it's experimental.
That's why the 135 makes so much sense, because it's like the grail of astrophotography. It just makes sense to do it. And then you got untold number of people who can just take their DSLR, clip it onto the 135, slap it on a tracker, and then boom, you've got a light pollution ready to go AP at 135 and capture Cygnus all week. I love it, man. That's smart. Very clever. Wonder why no one else thought to do that. I haven't seen anyone else doing that with 2-inch filters. This is awesome, man. I love it.
Yeah, there must be someone like.
I'm sure there is. I mean, no idea is new under the sun, but I love to see that you're doing it with your filters because it's very, very cool. So yeah, man, send one away, and I will absolutely check it out.
Do you have lenses that are M77?
Good point. Let me check and see first. I know I've got a 135. Obviously, I've got a Rokinon 135.
Well, I'll send it for that anyway.
Yeah, but let me look and see if I've got any others that are. So in other words, the 135 is M77, right?
Yes.
Okay, cool. Just making sure I heard that right.
Many lenses are also M77,
yeah,
but not all lenses.
I don't know if any of my others are. I want to say I may have. I'm thinking of my. Here, let me look and see. 77. Look at that. My RFL 100 to 500. That's 77. That would be a cool one to test.
Yeah,
too.
yeah.
Oh my God. Could you imagine? Zoom that into 500 millimeters, put it on the R7, and then put that on the AM3 with the light pollution filter? That would be sick. I got to give that a try.
That would, yeah. But do what Justin advises, which is use the ring as the aperture stop instead.
Yeah.
So
absolutely.
You set it wide open, and then use this as the aperture stop, because these photographic lenses, they don't always have perfectly spherical aperture blades.
Yeah. I'm gonna have to give that. Oh man, that's exciting. See, that's the kind of stuff I love to do, man. I love tinkering with gear and using it in ways people don't think. That's why I like Mark so much, man. When me and him started talking, he's like traveling the world and he's just using Canon gear. Like he doesn't even have a telescope. It's just all lenses, and he's making it work. But
that's the beauty of the wide field, is that you have so much more capability to travel, and like a lot of the good targets, you need wide field to do it. It's not all about having the longest focal length.
The favorite photo I have taken to date was when we took our Bortle 1 trip to the coast, and believe it or not, I was just using the 24-70 Canon lens, and it wasn't even on a tracker, man. I was just taking 10-second exposures of the Milky Way, and I took probably 100 of them, stacked them all together, and the image just came out incredible. And I even got me tinkering with the camera in the foreground, one of the other cameras that was taking photos, and I love that photo, man. It's my favorite. Do you get to see the Milky Way anywhere in Ireland, or is it too light polluted?
Well, this is the funny thing. So this is like I was saying, like I never grew up knowing much about the stars until I learned about them in college, and this kind of thing. But after at some point, I was visiting my family in Connemara, which is on the west coast, and it's generally quite remote. Depending on where you look on the map, it's considered like Bortle 0 to 3 in some places. Yeah, the west of Ireland has like 2 or 3 dark sky reserves.
Nice.
So it got to the point where I had started doing a bit of like visual astronomy at that time. Before I had the telescope set up for astrophotography, which is I was doing a lot of visual with it at the time. And I got there, and there was so many stars in the sky, I couldn't recognize anything.
Don't you? Isn't that the weirdest feeling when you're like, where'd all the constellations go?
It was disorientating.
It is.
I didn't know how good it could be. It was mind-blowing.
It totally, man. I know that feeling whenever you get out and you look up and there's just no reference points, because the sky that you see only has 20 stars in one given area, right? Like, and then you're like, oh my God, like it's like diamonds on velvet, man. They're just everywhere. Like when you get to those dark skies, it's so special, man. Just makes me wish we had more of it. So
yeah, it's mind-blowing. Yeah.
Right,
one thing before we go, so Horizon Astronomy, they're the first retailer to actually put it up on their site. Now, we're in Ireland, now based in Munich, and they're the first retailer to put it on their site. So, I'm actually had really good discussions with Andreas, who runs it. He's German Irish heritage, so that's the relation there. So, he was excited to take it on too, because he wanted to support an Irish business, and he had started his business recently. So this is the other thing, like from starting this business and getting to chat to retailers, you get to listen to the stories about how people have started their business, and that becomes very interesting. So
here it is. I went online and found the website. It's actually a really nice site. I've never been to, I guess I wouldn't have had a reason to, because I'm not in Europe. But that said, for all of our listeners that are in Europe, and we've got a lot, Horizon Astronomy is actually looks to be a really nice shop, and with a lot of different selection on it as well, I have to say.
Yeah, he's a brilliant retailer, and he's got tons of experience, and his shop is going through tremendous growth, and it's kind of going from strength to strength, especially now that he's based in Munich. He's got much stronger supply chains.
I can see that.
So it's really helping his business. And it's also, look at the calendar there. So that's, he also sells the Astrophotography Club Ireland calendar.
Oh, I love that. Yeah. So you guys have an official club, and these are photos from the club?
Well, that's actually quite an informal club. There is official groups, but this is actually, I know who runs it is Marty McCormick. He's brilliant astrophotographer. He does imaging from like Portal 8 in Dublin city centre. He runs this informal club as a Facebook group. And yeah, it's like a really good group for astrophotographers all helping each other. It's really nice, and it's not just deep space, but you can see they've got bits of everything.
Yeah, it's gorgeous in the sun as well. Oh man, I didn't know that all of this beautiful dark night. See, my image cut off right here. I didn't center it just perfectly. I think they put the tail of the dark shark in the middle of the frame. Yeah. So I didn't get any of this beautiful nebulosity over here. Man, what a great image. All of these are. Really, they are. That is awesome. So how long have you been on with Horizon now?
So we haven't marketed it fully yet, because it's been on his site for about a month, but we've actually kind of not promoted it yet, because one thing I noticed, one customer in particular, actually we talked about this briefly, and that's why I was asking you if it fit in your filter wheels and filter drawers.
Oh yeah.
Yeah, one customer in particular, it didn't fit in his filter drawer, even though the cell was designed to the specifications. But it's worked for everyone else. So I've revised the filter cell to be a few millimeters shorter, just to take that risk. In the end, I think it was user error in the end, actually. But that's still kind of not acceptable. That if some people aren't having a smooth experience with it, it's not good enough. I've revised the filter cell to be a little smaller, so I was just kind of waiting until that. So I have that done. So I have them packaged up and ready to go.
That's awesome. That's good to hear. I was worried whenever I first got mine, because I was like, this looks like it's going to be a tight fit. But I don't know. I just looked at it really closely, and then, I didn't even have to measure with calipers or anything. It was just like, here it goes, and it slid right in. So I'm glad to hear that he did get it to work. Well,
the original was designed to fit, and it does fit, but it is tight. But the reason I made it as large as possible is that it has both male and female threads. So if you imagine somebody could just thread it right in between their lens and a thing. I thought, to me, that just seemed the natural way to do it.
I love that, because it's just one less thing you don't got to worry about. Because how often is it in this hobby where you have to go out and buy 1, 2, 3 adapters for something, and then you get it, and then you don't even know if it works, and now that eliminates a lot of that, having it on both sides. That's wonderful.
Yeah, but to be clear, the latest version only has the male thread. It's more traditional in size to
but you
the
were able to
standard
make it
ones.
thinner, so
yeah, it is.
There you go.
But the larger one is still available if you ask me specifically. So if you if somebody does have so I'm going to be sending out the very low profile one to the retailers, because there's another retailer that it will hopefully be with very soon, but obviously I can't talk about that yet.
Yep. Oh, I know how that goes.
Just popping in from the future here. As I said at the beginning of the episode, that retailer is First Light Optics, and I've got a link for that in the show notes. Back to you.
So the retailers will be getting this one that's like, it's completely de-risked, it's small enough, it's tested, it's going to fit in everything. If you are somebody who doesn't mind a tight fit, or you have that specific case of needing the female thread, it's available. You just have to let your retailer know, or let me know if you're buying it off the site.
There you go. Do you have an email address, by the way, that you want to mention, James?
People can use the contact form.
Contact form on the website?
Yeah.
Excellent. All right. So you'll see the link to Leviathan Optical in the show notes, and if you just go there and click on the contact form, if you have any questions such as filter sizes and threads, etc., you can reach out to James that way. Cool. Awesome, man. Well, look, my wife's banging pots around in there, so I'm going to go catch up with her. But hey, man, I really enjoyed catching up with you, and let's do this again very soon, okay?
All right. Thanks so much. It was great catching up. And
you too, man.
Let's talk soon.
What a great guy James is. I just want to say a big thank you to him again for coming on the show to talk about the Spectral Pro and how filters are made and kind of everything under the sun that we did discuss. So always enjoy catching up, and it's super cool to say that I've got a friend from Dublin now. So thanks again, James, for coming on the show. Pretty much everything we discussed is going to be in the show notes. So if you're interested in getting one of the filters, please feel free to use those links. And then obviously, if you go to Leviathan Optical's website, you can see example images, including My Heart Nebula. And I'll try to post the Pleiades too, and you guys can see what I mean about it being a little bit of a unique image, but I do really love it. It's just a little bit different than some of the ones that I've seen. So that was a lot of fun. I definitely enjoyed it, and we are going to have more content like this in the future, so stay tuned for that. I just want to update you guys as well. I'm working on the edit for the NEAF episode, and I'm trying to do a little bit of a unique take on it, because so much of the content that I've seen since NEAF ended is just people going from table to table looking at the new gear. And don't get me wrong, that's very cool, and I appreciate looking at new gear, but we're going to do it a little bit different, as only the Astrocast can. So stay tuned for that. Should have that out within the next week or two. Thank you guys so much for tuning into the Astrocast this week. I am your host, Rue. I hope you're all doing wonderful. Galaxy season is slowly coming to a close. The Milky Way is starting to rise earlier in the morning. Venus is in the western sky just after dark. Make sure you check that out. The Pan-STARRS comet is possibly naked eye visible at this point. So if you haven't checked that out, definitely check that out. I'm going to see if I can see it one night this week, but we shall see. But it was wonderful catching up with you guys. We'll be out with an all new episode next week. I am your host, Rue. You've been listening to the Astrocast. And as always, clear skies.
Wednesday evening, the feed goes live. Rue's voice cuts through the dark like a 135. From backyard scopes to mountain peaks, we're all tuned in, no time to sleep. Red dot finders, coma correctors gain. He breaks it down like it's simple, never pain. Comets rising, planets in the frame. Every